Hi, this is Kumaravel, Assistant Professor AC from RMD Engineering College. Today's topic we are going to discuss about hazards. Hazard is an unwanted transient, that is spike or glitch that occur due to unequal path or unequal propagation delay in a combinational circuit. What does it means is at certain time interval I'm expecting my output of a given circuit is to be 1, but in that time interval instead of 1 if I'm going to get it as 0, right, instead of 1 I'm getting it as 0, right, this is called hazards, right. I'm expecting some output but instead of that I'm getting different outputs. Now we'll see types of hazards. So types of hazards for computational circuit we have static hazard. Static hazard is further classified into static 1 hazard and static 0 hazard. Okay, so we'll see what is static 1 hazard. Static 1 hazard is I'm expecting for certain time interval my output should be 1, but instead of 1 I'm getting my output as 0 for the same time interval. This is called static 1 hazard. I'm expecting 1 but I'm getting 0. Okay, this is static hazard. So that is static 1 hazard, right. Then what is static 0 hazard? So for this certain time interval I'm expecting my output to be 0, but instead of 0 I'm getting 1. This is static 0 hazard. Okay, the next type of hazard for combinational circuit is dynamic hazard. Dynamic hazard means instead of single change in your output, if your output keep on changing between zeros and 1, then this is called dynamic hazard. Similar to combinational circuit, for sequential circuit we have essential hazard. We will see them in detail. Now let us consider static hazard. So to understand what is static hazard, let us consider schema for the function a, b, c, the sum of 0, 1, 2, 6. So now we'll plot an schema for this. So let us consider the inputs are a, b, c. So for 0, so you will have 0, 0, 0. For 1, 0, 0, 1. For 2, 0, 1, 0. For 6, 1, 1, 0. So first case for 0, 0, 0, 0, therefore 0, 0, 0. So here, okay, next for 1, 0, 0, 1, 0, 0, 1 here, then for 2, 0, 1, 0 here, for 6, 1, 1, 0, 1, 1, 0 here. Now if we group this, so we can group these two and we can group these two, then we can write function f as ab whole bar plus b into c bar. Okay, now if we draw an logic circuit for this, we can draw it as a bar, b bar. It is given as an input to AND gate 1. Similarly, b into c bar, b into c bar to second AND gate. Two AND gates outputs are given to OR gate. Okay, so now let us consider an example. Let us consider a, b, c when all the inputs are 0. So now let us see what happens to our output. So now the inputs are 0, this will become 1, 1, 0, 1. So my first AND gate output is 1 and my second AND gate output is 0, but still here I am having OR gates, therefore my output of my OR gate is 1. Okay, now let us consider, okay, when b changes to 0 to 1. So 0, 1, 0. Now what happens? A bar is 1. Now B bar is 0. What happened to first AND gate output? Now first AND gate output is 0. Now similarly, when this input is applied to second AND gate, what happens? Your B should be 1 and your C bar should be 1 and your second AND gate output should be 1 and we are expecting our output to be 1. But here what we have to understand is, so now when B changes from 0 to 1, your first output, first AND gate output changes to 1 to 0. And let us assume here, so if your second output take some time delay to respond to the input. So now what happens? So now what happens? It will take time to change to 0 to 1. In that time interval, your both AND gate 1 and AND gate 2 outputs are 0. So in this time interval, what happens to your output? Instead of 1, you will get 0. This is nothing but static hazard. Okay, for certain time interval, if your AND gate 2 is doesn't respond, right, or it will take time to respond, right, in that time interval what happens? So we are expecting our output to be 1, but instead of 1 we are getting output as 0. This is called static hazard. So now we will see how to eliminate this static hazard. Okay, static hazard can be eliminated by overlapping the grouping. So overlapping the grouping in the sense what? So we have group 1 and group 2. These groups can be overlapped, right? How we can overlap this? We can combine these two. If we combine these two, then your function become what? It will become A bar into, not B, sorry, A bar into C bar. Okay, so now if you draw a logic circuit for this, so we have A bar, B bar, B, C bar. Apart from this, we have what? A bar and C bar also. Now we'll see with the same example how your static hazard can be eliminated by overlapping. Okay, so now the same case, when A, B, C are 0, 0, 0. So we know that what? Under this case, gate 1 output is 1 and gate 2 output is 0 and gate 3 output is AND gate output 3 is, sorry, third AND gate output is 1. Okay, your OR gate output is 1. We have seen that what? When B changed to 1, so first AND gate output become 0, and if your second AND gate it take time to respond, these two become 0, your output become 0, your OR gate output becomes 0. This is what we have seen in the previous case. Now how this is eliminated here? See, here you will have A bar and C bar. So now what happens? A bar and C bar, so your A and B variable doesn't change, therefore we have 1 and 1 here, therefore it is already 1, it doesn't change. So even if this, for that even a short interval time, when your AND gate 1 and AND gate 2 outputs become 0, 0, still your AND gate 3 output is 1, therefore your output of your OR gate is 1, output of your OR gate is 1. Therefore, so by overlapping the grouping, we can eliminate the static hazard. Dynamic hazard is similar to static hazard. We can do the same procedure to eliminate the dynamic hazard. Now we will see what is essential hazard. So for essential hazard, let us consider an flow table as well as asynchronous sequential circuit. Right, so here, so what I'm going to do is, let us consider the present state and next state. So what happens to my next state when x equal to 0 and x equal to 1? For an example, if I consider my present state is 0, 0, when x equal to 0, my next state is 0, 0 itself, but when x equal to 1, my next state is 0, 1. Okay, now we'll see what is essential hazard. For an example, let us consider x equal to 0. So here also 0. Okay, my present state, that is small y1, small y2, small y1, small y2 are 0, 0. Okay, so now we'll see what happens to my next state. What happens to my next state? Okay, so if here it is 0, then y1 bar is 1. Okay, y1 bar is 1, so this 1 is feedback here and this 0 is feedback to here, and this 0 is feedback to here and here. Okay, so now when my x equal to 0, this will become 1. So 1 0, here it is 0. So here it is 0 0. So 0, my y1 equal to 0. Similarly, what happens? 1 0. So this will be 0 0 0 0. So when x equal to 0, my present state is 0. My next state is also 0 0. Okay. Now let us see when x changed to 1. X changed to 1. So here also x changed to 1. So now let us see when x changes to 1. So what happens when x changes to 1? So here 1. So previously we have 1 here. Okay. So this will become 1. When this become 1, so what happened to your second OR gate? This will become 1. So y2 become 1. When y2 become 1, your D flip-flop, second D flip-flop output will become 1. Okay, this will be feedback to your input. So here 1, so here 1, so here if it is 1 means, so here also 1, right? So here 1 means here you will have 0. So 0 1, here output will be 0. So here what happens? So it is still 0 0 once, here it is again 0. So here it is 0. Okay, when x change to 1, so your next state output is 0 1. This is what we are expecting. But right, so what is essential hazard is, let us consider there is some time delay. There is some time delay in your NOT gate. So due to this time delay, so your NOT gate output, that is swapping between 0 to 1, it will take some time. It will take some time. So then what happened? In that time interval, let me consider a different color. In that time interval, so what happens? So instead of your NOT gate output, instead of change to 0, it is still in 1 itself. If it is in 1, then what happens? If you compare these two, 1 and 1 are applied as an input to first AND gate. So this output become 1 instead of 0. Okay, then your OR gate 1 output become 1 instead of 0. Therefore, your next state is 1 1 instead of 0 1. Instead of 0 1, it will become 1 1. This is due to what? Delay in your NOT gate output. Right? This is called essential hazard. Okay, this is called essential hazard. Essential hazard can be eliminated by, we can increase the delay in propagation in your feedback path. Okay, thank you.